After I had my kids, I found out that I'm a carrier for a genetic disorder, so it got me interested in that kind of direction.
Oh, wow. You know, I used to teach, I guess, what is the word? Humility aside, a really good genetics course. They don't have genetics here at BCC, but when I was at a different university, that's a little bit of my background besides chemistry.
I heard you saying that once, that you were
Yeah.
coding
Yeah,
genes
yeah.
for like 6 months.
Oh, God, yeah. Now you can do it in 2 seconds. But genetics is fascinating. Okay, just a quick housekeeping reminder here. So just this morning I added chapter 5 as, because we're going to be moving to that chapter probably even today. But it's not due until the 5th of November. So you have about 2 weeks to do that work. You do have only 1 week to do chapter 4, which we're going to pretty much finish today. And then, this is important, everyone, the first exam. Completely online, no time limit other than, it's open now. You have the entire week to complete it. But don't start that exam until you finish with the homework for chapter 4 and until you finish with the quiz for chapter 4, because it is included in that exam.
But we don't need the information from chapter 5.
You do not need the information for chapter 5, so it includes only 1 through 4, that first exam. And only 1 attempt, which, please don't be frustrated, upset, worried. If you get, say, a 70 on the exam, 70 or 85 or 80, and I'll explain actually in the context of today's lecture why that should not worry you. There's so much other work that will help your grade get to where you want it. The exams are a very small part, very small percentage of the final grade. And we'll take a look at that in a few minutes with an example of chemistry, by the way. So let me just verify one thing here on the syllabus. I think each exam is only worth 5%, but I want to make sure. Oh no, they're worth 10%. So 10% is not huge, but it's of course more than 5. So we'll talk about what that means in the context of this chapter that we're going to start today or continue today. Now, I also place the readings in the folder for lecture materials, for textbook readings. And let me open, oh, that's not there yet. Okay. Let me start by, once again, and if I said this last week as an introduction, please just, use it as a quick review by showing you something called the periodic table of the elements. Now, as you have heard me say several times, chemistry is the study of matter. Everything that occupies space is considered matter. And every single thing that you see, that you touch, that you smell, that you eat, is composed of a combination of these ingredients. There's nothing more in the universe. This is it. Now, there's about 100 of the ingredients here, but nevertheless, only about 30 of them are predominant. The others are minor. I mean, things like mercury, where mercury we don't really want it in our diet, right? Or we don't want to be touching it. Is useful for other things, but we don't deal with that as part of life. Zinc, on the other hand, is a mineral that you probably needed, just like copper. But then we have the very, very common ones on top here: carbon, nitrogen. Every living cell has carbon and nitrogen, and it needs oxygen, so it has oxygen. And then you have hydrogen there. So there's altogether about 100 elements, but only about 30 are common in living things, and only about 10 of them are like the bulk of everything that makes up a living entity. Of course, the table is made up of really weird combinations of other elements, but that's not alive. And you are taking this chemistry course most likely because you're going to be working in some allied health field or something like that. Now, we're going to spend 2 chapters basically trying to understand this table, which is known as the periodic table of the elements. But we need to start building our understanding by analyzing one individual atom as an example. And I'm going to choose carbon, just because that one is part of every living thing. I could have chosen oxygen or hydrogen. But let me just stay with carbon for now. Now, every element, every chemical element is composed of atoms. So element and atom are not identical. They're not the same thing. They can be used many times as the same meaning, but elements are composed of atoms. Atoms don't know if they are oxygen or hydrogen. They are just basically ingredients of elements. So there are some subtle differences. I would say it's like this means humans and this means individual humans. So humans in general, and then me as Mario, you as Agnes, whatever you have. Different people, different names. So atoms are humans, elements are individual persons. Does that make sense? Okay. Now we're going to talk about carbon as an element. So carbon is an element. And that element is composed of carbon atoms. Sounds a little confusing, but it simply means that the person carbon is made up of atoms of carbon. Now, let's take a look at a generic atom. There's been many pictures, cartoons, if you will, of atoms through the years. I think I may have mentioned this last week to you, but sometimes if you Google the word atom and you look for images, many, many times you probably find something that looks like this. It has a little center, a sphere in the middle, and then it has these loopy things around. Have you seen that before? That's way, way off from what we believe the real atom looks like if you could magnify it. Nobody really can see that level of detail. There's no microscope that is strong enough to bring you to that level of detail. But there is evidence that more than that, an atom looks like this. A tiny, tiny core. So I'm going to put it bigger than it probably is. But that's the core. Surrounded by space that we're going to call orbitals. They're like a cloud that surrounds this core. And those clouds can be very close to the core or a little bit further away. So this is more what really is all about than that. Now that core is called the nucleus. And it can be a little confusing because cells also have a nucleus. Well, they're different. In both contexts, it means the center of. So the nucleus just basically means the center of the atom. If you were to try to picture this in 3 dimensions, and I hate to use analogies that, well, in this case, you probably are not football players, right? I mean, if you play football as children, and I mean American football, not soccer, that's not necessarily very common. It's not a girl's sport, right? But you have seen football fields in your lifetime, right? Or even a soccer field. Well, imagine an atom being that football field. So that's the size of this whole thing. This whole thing is the football field or the soccer field. And now imagine a small ball, maybe even a football ball or a baseball ball. Put it in the center of the field, and that's the nucleus. So the atom is huge, but most of it is empty space. Most of it is not the nucleus. It's actually all of this empty space. Now we're going to call these areas with a common name. We're going to use several names, but 2 of them are shells or orbitals. And these are spaces around the atom. Now, every single atom, whether it's carbon or oxygen or anything else, has 3 main ingredients. It doesn't matter what the atom is. It can be carbon or hydrogen or oxygen. It has 3 ingredients. In the nucleus, it has something called protons. And that's just the name of the ingredient of the building block, and neutrons. Those are the 2 things that are located in the nucleus and that make up the nucleus. Okay, so these are just ingredients. On this space around, you have the electrons. So the electrons do not reside or are found in the nucleus. They're found in this space around the nucleus that is called a shell. Okay? Now, we're going to make a little table here of the ingredients. So I'm going to call them ingredients of all atoms. And I'm going to put those 3 because that's what we have. So we're going to start with the protons. And then we're going to put the neutron or the neutrons. And finally the electron. And that's it. At least for this course of chemistry. There's other chemistry courses, more advanced, maybe even in physics, where they talk about other ingredients of atoms. But they don't have any importance for us in the context of this course. So these are the 3 that we're going to talk about. Now let's make a little table. And we're going to put here the location, where it's found. Then we're going to put here how heavy that is in relation to the other ingredients. So I'm going to call it the mass, which is the weight, okay? And then we're going to talk about something that you are familiar with, but we're going to put it in a slightly different context, something that I'm going to call the charge. And I'll explain what I mean by that in a minute. So the location of the proton, as I indicated in that drawing, is in the nucleus. The neutrons are also found in the nucleus. And the electron is found in the orbitals, or the shells. That's the location. Now, how heavy are these things? Well, if I were to show you the mass of a proton in grams, which is the unit that we're familiar with, this marker weighs probably, I don't know, 50 grams, maybe 2 ounces. I don't know, it's a guess. One single proton, and this is a rough estimation, weighs about 1 times 10 to the negative 24 grams. Negative 24. That's 0.00000. So it's tiny, 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 tiny in weight. That's about the mass of a proton. Well, writing that would be too complicated. So chemists came up with a new unit. It's not the gram. It's called the AMU. So let me write it here. I'm going to give you the unit as AMU. Sometimes it's just called U's. So AMU stands for atomic mass unit. And you don't need to repeat it or memorize it. Just think of it as a gram, but it's 10 to the negative 24 grams. So 1 AMU is what we say is the mass of a proton. Now, as you know, in the metric system, 1 AMU is 10 to the negative 24 grams. So tiny, 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 tiny. The nucleus, sorry, the neutron is about as heavy, weighs about the same. 1 AMU. Give or take, a fraction. But here comes something that you have to believe me when I tell you. The mass of the electron, and don't write it down because I'm going to erase it. The mass of the electron is 1 divided by 2,000 AMUs. If we do that math, it's like 0.0000 something, okay? Comparatively speaking, that's almost nothing of the mass of a neutron. I mean, imagine if you weighed something and then you weigh something else and it weighs 2,000 times less. Well, you need 2,000 times those to have the same mass as one of them, of the others. Does that make sense? I got a little confused on that one. But I think you see the point. So why am I going to erase it? Because we're going to make an easy assumption. It's not true, but it's useful. We're going to say that the electron weighs 0. As you can imagine, it's not true, right? It's just convenient to say, you know what? It's so light that it doesn't matter that much. And you'll see why we need these 3 numbers right here very soon. All right, so that's the mass of the 3 ingredients of every atom in the universe. There's something called a charge, and this means electrical charge. you sort of have an idea what an electrical charge is because everybody has used batteries. You put batteries inside of different electric devices that need power, that need energy to function. Your computer has batteries inside, your phone has batteries inside. Well, every battery, if you think about it, has this label. If you look at a AA or a AAA battery, everybody has seen one, it has a positive end and a negative end, right? We're going to just simply call those positive charges and negative charges. We don't need to understand anything more except two things. Positive pushes away positive. They repel each other. And positive attracts negative. As a consequence, negative also pushes away negative. Okay. And we are going to simply assign an electrical charge of either positive or negative to these three ingredients. And here we go. The proton has a charge of 1 plus. It doesn't matter what 1 means. It's just 1. The electron has a charge of 1 minus, or negative 1. I can put the negative in front. It doesn't matter. 1 minus, 1 plus. Plus 1, minus 1. And the neutron doesn't have a charge. So it's neutral. It's neither positive nor negative. So it has a charge of 0. Now with this table of ingredients, we can start building all of the elements on the periodic table using drawings like this and positioning or placing the different ingredients where they belong. So let's do that for, yes, Rachel.
So since the neutron has
No charge.
A positive or a negative could go to it?
Correct.
Okay.
It's not going to be repelling it. Now, I'm glad you asked that question because here comes something that you should question, but then I'm going to tell you just to basically ignore it. And I know it sounds silly, but let's take a look at the simplest of all atoms. Before we go to carbon, let's take a look at the simplest of all. It doesn't get any simpler than hydrogen. Hydrogen is the first element on the periodic table. Trust me, I'll show it to you in a minute. But hydrogen has the name, of course. It has a symbol. And here are the ingredients of hydrogen. Hydrogen has 1 proton. I'm just going to abbreviate it with a P. Hydrogen has 1 electron. I'm just going to abbreviate it with an E and a negative sign just to make sure that I remember that the electron is negative. Now here comes a problem. Even though this is the simplest of all elements, it already throws a curve at you. Because there are 3 different types of hydrogen in the universe. There's not only 1 hydrogen. There's 3 flavors, if you will. The 3 are hydrogen for the following reason. Any atom in the world, in the universe, that has 1 proton is hydrogen. No more discussion about that. What I just told you is that the number of protons gives you the identity of the atom. So if an atom that you discover has only 1 proton, it has to be hydrogen. It cannot be anything else. Unfortunately, the 3 flavors of hydrogen have 3 possible numbers for neutrons. There is a hydrogen with 0 neutrons, there's a hydrogen with 1 neutron, and there's a hydrogen with 2 neutrons. These are neutrons. A little confusing, isn't it? Well, let's take a look at the simplest of all hydrogens, the one with no neutrons. and let's make a drawing using that diagram. Now, of course, I need space, so I'm going to make that little nucleus a little bit bigger. I'm going to put it as a circle. And I'm going to put here a 1p, 1 proton in the nucleus. And then I'm going to draw one of those shells. I'm going to draw only one because I don't need the other shells. They are there, but they're empty. The first shell, the one closer to the nucleus, is not empty. It has that one electron. So we said that hydrogen has one electron. So that electron I'm going to draw as a dot, and that's the one electron. So the one proton in the nucleus, the one electron in the first shell, in A shell, and that's hydrogen. Now there's two other flavors of hydrogen. Here is the nucleus, one proton, one neutron. Still only one electron. So second flavor of hydrogen. I know it's still hydrogen because it has one proton. Don't forget that. If it has one proton, it's hydrogen. If it has two protons, it's something else. Third type of hydrogen flavor. One proton, two neutrons. Only one electron on that shell. All these three drawings represent hydrogen, but there's three different flavors of hydrogen. Before I give you a name that describes when you have different flavors of the same element, let's take a look at the properties of these three as far as electrical charge and mass. So what is the electrical charge of this hydrogen? Well, remember that I told you that the proton has a charge of +1 and the electron has a charge of -1. You're going to look at these numbers just as you do in arithmetic, in math. +1 plus -1 gives you 0, right?
Yep.
They cancel each other out. So the electrical charge of this atom is 0. There's no charge. Same thing for this, one proton, one electron. The neutron is 0 as by definition, so it contributes no charge to the atom. And then this one is also 0. +1, -1. Two neutrons don't matter. I'm not even going to write it down because it's that simple, but the mass, I'm going to write it down. The mass of this guy, all you have to do is add AMUs, these numbers. So how many protons in the nucleus? 1. How many neutrons? None. The electron weighs 0, so it doesn't matter. So 1 plus nothing else, the mass of this atom of hydrogen is 1. 1 AMU. How about this second flavor of hydrogen? The mass of that atom has 1 proton, has 1 neutron, which weighs 1, and the electron doesn't weigh anything. So the mass of this is 2. Right? You agree with me? Okay. Finally, the third flavor of hydrogen has a mass of 3. I hope you see why. It has 2 neutrons and 1 proton. Now, these guys, because they're all hydrogen, are what we're going to call isotopes of hydrogen. Isotopes is like, I don't know, twins, if you will, or triplets. You know, they're siblings, they're identical almost, but they're slightly different. Well, instead of calling them triplets, we're going to call them isotopes. Hydrogen has 3 isotopes, right? One of them has a mass of 1, one of them has a mass of 2, and the third one has a mass of 3. So far, so good. All of them have 1 electron, no charge. Well, there's another number that we're going to introduce today called the atomic number. So I'm going to call this the atomic mass, just to be perfectly clear. When I call it mass, it's a little ambiguous. It doesn't tell you very clearly the mass of what. But if I tell you atomic mass, that means the mass of the atom. So the atomic mass of these 3 hydrogens are 1, 2, and 3, respectively. There is another entity called the atomic number. And I'm going to put it down for you. I'll explain it in a minute. The atomic number of this hydrogen is 1, 1, and 1. That's the ID. That's the social security number of the atom, the atomic number. So check this out. The atomic number of any atom is always equal to the number of protons. I'll repeat that again. The atomic number is equal to the number of protons. What is the atomic mass equal to? I mean, we did the calculations here. 1 proton, 0 neutrons, 1. 1 proton, 1 neutron, 2. 1 proton, 2 neutrons, 3. So what is atomic mass?
Because that includes both the protons and the neutrons.
Exactly, and that's what it is. So the atomic mass is always the number of protons plus the number of neutrons. So the atomic mass, protons plus neutrons. Okay, so far so good. Nothing too complicated. But here comes the complication. If I were to look at the periodic table, and I'm not going to turn it on yet, but I'm just going to copy the information about hydrogen straight from this periodic table, and then we'll look at your book's periodic table. Hydrogen, there's a symbol like a box like that, then it has a big H. That's the symbol of hydrogen. It has the name underneath. I'm just not going to write it. And then it has 2 numbers. It has a 1 on the left, and then it has a 1.008 on the right. 1.008 on the right. Now that's from the periodic table that I have on my screen. Let me get the periodic table from your book.
It doesn't show the little 1.008.
It doesn't. Okay. So let me see if I can find another periodic table in your book that shows that. Come on. There should be one really. Okay, I'm going home to the. Oh, it's taking me to the Pearson home. Let me turn this on so that you know what I'm doing. So thank you for that, Rachel. I wish they had one. Oh God, Google Chrome takes.
Mine on my computer the same as yours.
Let me take a look.
No, I saved it.
That one is from a website, right?
Yep.
So that's the same that I have. I need to see the one from your book.
Yeah, she has.
Oh, let me see it.
Like I have that.
Okay, but there's another. Okay.
It just has.
It has only the one. Okay, let's see if we can find another one in the book. There should be another one.
This is the one from 4.1.
From 4.1, okay.
If there's another one somewhere else.
Yeah, in the cover, in the front cover or in the back cover of the book. Yeah. It could be on chapter 5 also. Let me just, I'm scrolling down through the chapter. I mean, that is great, but it's way too simplified. I want to show you at least another example of how they are shown on different types of periodic table. I mean, I wish they were all uniform and the same. Still not showing it. I'm already in section like 4.4. Okay, here. Okay. That's from your book. And that one does show two numbers. Now this is from your book. It's different from the one that I put on the board. So I'm going to reproduce that for hydrogen. And unfortunately, then I'm going to add another one. Okay. So the periodic table that you're going to end up seeing in your book is going to have hydrogen, and then it has a number on the top, and then it has a number on the bottom. And then I'm going to give you one third way in which you may encounter the same information. Hydrogen, 1.008 on the top left, and then one on the bottom left. If you notice, these three have the same information. Okay? But in different places. Now, I'm going to use this diagram, the third one, to put the identity here on the bottom with a symbol. So I'm going to write hydrogen, a 1 and a 1. Hydrogen, a 2 and a 1. Hydrogen, a 3 and a 1. So these three symbols are hydrogen written in a notation that I want you to remember as top heavy. So top heavy meaning the big number is on the top of the symbol. Now, hydrogen is the most difficult to see these than other elements for simply the reason that both of these numbers are like a 1. But here goes something that you should remember. If you forget what number is what, remember one of these two numbers is the atomic number, and one of those two numbers is the atomic mass. Every symbol is going to have the atomic number and the atomic mass, except for that table, Rachel, that you were showing me, that only has the atomic number. But if you see two numbers, with the exception of this one, which is kind of bad, one is bigger than the other, right? The bigger number is always the mass number. The smaller number is always the atomic number. And then you don't have to worry about it. Now, why do we have a 1.008 for the mass of hydrogen instead of having a 1, a 2, or a 3? Well, the periodic table of the elements gives you the atomic mass of the average of all isotopes for that given element. Hydrogen has 3 isotopes. One like that, one like that, one like that, and it has an average mass of 1.008. You should be telling me right now, wait a minute. The average of 1 plus 2 plus 3 is not 1.008, right? I mean, how do you calculate the average of of 3 numbers? Exactly. So, let's write here average. And then here we're going to write something else in a minute. So if I want to get the average of 1 plus 2 plus 3, I need to divide that by 3, right? So 1 plus 2 is 3, plus 3 is 6, divided by 3, it gives me 2, right? That's the average. This average right here is not a straight average like this. It's something called a weighted average. And that's different. The best example of a weighted average that I can give you is your grade calculation. I'll show it to you in a minute. So can I erase this table? Okay. So let's do let's pretend that in this class we have only 3 assignments that are graded, and at the end of the semester your grade, your final grade, is calculated as follows. You have homework, you have quizzes, and you have exams. Only one exam to make it easy. The one exam is worth 10%. Right? Well, just for, it's an example. The quizzes are worth, let's say, 50%. And the homework is worth 40%. Okay? Just in my example. If you get an average of the following grades, let's say that for this example, your homework, well, you have unlimited number of attempts, so you get 100. In the quizzes, you only have 2 attempts or 3 attempts, so you don't get 100, you get a 90. And the exam, because you only have an attempt, you really get a very bad grade. You get a 60. A 60 on the exam. So what is the average of that? The simple average, the regular average. That plus that divided by 3. Thank you, Rachel. So 100 plus 90 plus 60 divided by 3?
That can't be right. Hold on. 210.
Okay, divide that by 3. 70?
Yeah, 70.
70. Okay. So 190. Oh, I'm getting a different number. 9615. I get 250 divided by 3. 250 divided by 3.
250 divided by 3. 83.3333.
Okay, so the straight average of these, 83.3%. That's your final grade if I calculate a straight average. But wait. This is good news for you because the exams are worth only 10%. So here is the weighted average. And this is how you're going to calculate isotopic masses too. So what we're going to do is we're going to multiply this number by that number in decimal. Okay? So 10 times 0.4 gives you 40 points. So 40 is the contribution of the homework to your final grade. 90 times 50% is 45. Boy, look at that. Even with a 0 here, you already have an 85, which is higher than that. 60 times 0.1 is 6 points. If I add that, is 85 plus 6 is 91. That's good, right? Because the weighted average, and I think it's more or less the way it is for the course. Except that exams is 30% because there's 3 of them. Well, in the course, there's 3 exams, so each of them is 10%, so it's 30%.
I know what I'm saying. Which one are you using? This one?
I'm using this one. I'm using the weighted average. Okay, so now here comes the reality is that this 1.008 comes because one of these 3 is more important than the other 2, just as the quizzes were more important than the other 2 because they were worth 50%. Okay, now let's take a look at the example with hydrogen. And I'm not going to calculate it. I'm just going to tell you where this number comes from, the 1.008. So if you take a sample of hydrogen in nature and you check with really fancy equipment to see which of these 3 you have and in what amount, you have 99.9% of these. So almost all hydrogen is like this one. You have only like 0.01% of that and almost nothing of that. It does exist, but it's like 0.000001. So when you do a calculated weighted average for hydrogen, the number is very close to the one that you have the most of. You see, there's a little bit of something there because there's a little bit of this and a little bit of that. So that raises the weight a little bit, but very, very, very little. We're going to do an experiment, a problem, so that you see how this works for real, from the homework or the quiz. But that's how you do it. You get a weighted average. Now, let's take a look at a different element, carbon, for instance. So carbon has the symbol C. So let's erase this and put the 3 flavors of carbon that exist. And you're going to help me complete this table, just as we did it for hydrogen. Okay. So now we are using carbon as example, symbol C. I'm going to put here the one that I have on the screen from that periodic table that I was showing you earlier. And for carbon, they have 6 on the left and a 12.0, God, I forgot. 0.11? Thank you. 12.011. Which, I could actually write like this, or any other possible variation of that. The point is that the bigger number is the mass. The smaller number is the number, the atomic number. Okay. There are 6 protons in carbon. Okay? There are either 6, 7, or 8 neutrons in the 3 flavors of carbon that exist. And there are 6 electrons in carbon. So, here comes the first question. What is the atomic number of each isotope of carbon? 6 for all 3. That doesn't change. That's what gives carbon its identity. So the atomic number of the 3 flavors of carbon is always 6, the number of protons. What about the mass? Well, it depends on the number of neutrons, right? So I'm going to put 6p here, 6p, 6p. We said there were 6 electrons, so there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 electrons. 1, 2, 3, 4, 5, 6 electrons. But what about the mass? Well, if we have 6 neutrons, what is the mass? What's the mass number? What is the atomic mass of a carbon that has 6 protons and 6 neutrons? Yeah, it's not a trick question. 6 plus 6 is 12. What about this one? 6 plus 7. That would be 13, right? It's not a trick question. If this one has 8 neutrons, neutrons. 8 plus 6, 14. And those are the 3 flavors of carbon that exist in nature. So you have another way of writing them would be C12, C13, C14, all of them with a 6 on the bottom. 3 different types of carbon. Carbon 12, carbon 13, carbon 14. Now, why is the mass number 12.011, the weighted average? Why is not 13, which is the average of, because the different kinds of carbon are present in different amounts. The most common one is this one. So it favors the 12. There's much less of that and much, much less of that. Say that again?
Oh, the neutron. Okay, I was looking to see where you get the 7. I see.
Right, so this one has 7 neutrons, this one has 8 neutrons, this one has 6 neutrons, just different amounts, numbers. Now, let's do a problem from the homework, I believe, in which you have to actually calculate the atomic mass using weighted averages. Let me see if I can find it. And then I'll put it on the screen. And then we'll answer other questions so that you see how straightforward this is. It's not that complicated. Except that, of course, it has a lot of information that you need to be able to process and then eventually locate. So far, what I'm looking at on problem 8, all of them except for one we can answer with the information that you already have. So we have covered quite a bit. Wow. Maybe there's not a single problem. There's not a problem like that in the homework. God, that's a good thing. let me take a look at the quiz, okay? The homework doesn't have any weighted average problems. That's good news for you. Because it can get a little tricky. But let's take a look at the quiz. Okay, and then I'm going to open them for us to see how good we are. Well, that's wonderful. We don't have to worry about doing those calculations because there's nothing in the homework or in the quiz that is going to make you calculate weighted averages. That's actually a relief. So let's talk a little bit more about the periodic table, and then you're going to see how easy it is to complete this chapter. I mean, we have almost all the information we need now to deal with these questions. Now, you guys use probably on occasion, well, if you have never used what I'm going to ask you, if you have used, please forgive me, but you know what a GPS is? Or have you ever used your smartphone to go from point A to point B? You need to find an address and you enter it on the phone. The periodic table is like a GPS of all the elements. So if I tell you, okay, you need to find the element found on period 3, group 5, I just gave you the address of that element. So let's take a look at what I just said. So the periodic table of the elements has columns that are vertical, okay? And there are unfortunately two ways of numbering them. One is the American system, which is being basically eliminated. And a second one is the Worldwide Chemistry Association of Scientists numbering system, which is the one we're going to emphasize here. Group number 1 at the top of the group tells you all of these elements are in that group. Number 2, and then it goes continuously 3, 4, 5, all the way to 18. No breaks, 1 through 18. So there are 18 groups.
So the groups go horizontal?
Exactly. Well, yes, there are columns that are vertical, but you go horizontally, yes. 1 through 18. In the old system, in the American system, this used to be called 1A, 2A, and then 3B, 4B, 5B, and then this would be actually called 3A, 4A, 5A, 6A, 7A, and then 8A. It's a little complicated, right? Let's just stick with the 1 through 18 non-stop. Then, across, we have these rows that we're going to call period. And they're numbered very simply 1 through 7. Period 1, 2, 3, so on and so forth. So if I tell you, find the element on group 15, period 3, we go to group 15, and then down to period 3, and it's this one right here. And that's the only one that lives there. Phosphorus, right?
Yeah.
Period 3, group 15. There's nothing else there. Now, what do you know about phosphorus now? That the symbol is P, that the atomic number is 15, so it has 15 protons. The atomic mass is 30.9737. So that means that there's isotopes, because it's not an even number, because it's a weighted average. And of course, the different isotopes will have a different number of neutrons. Now, let's take a look at the color coding here. So this very first group, with the exception of hydrogen, is color-coded. Please don't ask me what color that is, because I'm colorblind. Well, let me tell you what color I see, and then you tell me if you agree. Let me start with the easy one. To my eyes, this is like a blue. My wife may tell me, no, that's purple. Is it purple? Yeah. Okay. So blues and purples, I kind of confused. This, to my eyes, looks pinkish. But I don't know, how pink or how red it is. Now, here comes a little bit of a difficulty for me, because I see two different colors here, but they don't stick out to me the way they do to you, or they don't to you.
They don't stick out that much to me.
Okay. I will say that this is green. And I will say that this is yellow. No? Maybe? That's not an exam. So I have color blindness, which means I see colors different than you. I do see colors. It's not like I'm blind to colors, but I confuse them. In fact, let me show you very quickly. I should be pausing this. There are plenty of colorblind tests in the internet. Now, this is going back to what Rachel was saying about genetics. Colorblindness is sex-linked, meaning I only have one Y chromosome and one X chromosome, because my biological gender is male. You guys, if your biological gender is female, then you have two X chromosomes. You don't have a Y. It turns out that the gene that determines whether or not you can see colors normally is on the X chromosome. It doesn't exist on the Y. So I only have one copy of the genes that allow me to see colors. And if that one copy is not good, then I'm colorblind. And who did I get my X chromosome, my only bad copy of the gene color?
From your mom?
From my mom. My father gave me my Y. He did not contribute anything to my eyesight. But I got my X chromosome from my mom, who got it from her father, and her father is colorblind. So colorblindness skips a generation on your mom's side for males. For you females to be colorblind, you need to have two bad copies. That means that your mom is a carrier, in other words, has a father who was colorblind, and then that your father is colorblind. So that's a double whammy, yes.
My daughter is legally blind.
Okay.
That's because I have the ABC gene, ABC4, and my husband too.
Ah.
We have two. I have a good and a bad. He has a good and a bad. She got my bad, his bad. So
Double
she doesn't
recessive,
have the good.
yeah. Yeah, so that's the thing that you face right now, that you had to go through genetic counseling. You probably discovered that through genetic counseling too. Yeah,
Mine
so
is on the X chromosome too.
it's on the X chromosome.
Yeah.
It's fascinating, but anyway, I guess it's a little break here.
So for mine, a father can only pass it to his daughters.
Correct.
He'll always pass it to his daughters.
Correct.
But for a mother, it's 50-50.
Exactly. So mothers can be carriers.
Yeah, my daughter, she was 50%. My youngest is 25. They say she doesn't have it, but I want to do the test again. And whoever, if I have any more kids, to do the
50-50,
test.
yeah,
And my
right.
daughter, she had a kid. Like everybody from now on have to do the test.
Yeah, and that's, it's the way genetics works. And in the not too distant future, they're going to be able to fix those defects by inserting good genes. That's not too far in the
They
future.
have a lot of trials and, I don't want to put it on trials, but they have at least 3 different things that they try to do.
Yeah, no, there is coming. Well, anyway, very quickly, so that we can go back to the discussion. I don't see a number there. 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 I don't see a number. I don't see a number. I don't see a number anywhere. Now, I may be able to see like a 2 here. Maybe a 3 or an 8. But I don't see it. I see colors. I can tell you that there's yellows here, pinks, reddish or maroons, but they're all blend together. I mean, they're different, but they don't form a pattern. And what I've been told from people like you who have normal vision is that there's a number here, either maybe in green or, what number do you see here?
60.
16? 60.
16.
Yeah, I know. I trust me when I tell you. Where is the one? Like right here? No. Here?
Yeah.
I don't see it. I do not see it. I see a bunch of dots of different colors. So when comes fall, and we're driving, and my wife goes, "Oh my God, look at that tree! It's changing. It's a beautiful red." And it's like, "What are you talking about? It's brown." So the yellows I can see. Some of the oranges also I can see very well. But when it comes to reds and greens, those melt together. Now, don't be afraid of driving next to me because I do see the red and the green on the stoplights. Well, and also because they make them very different. Right. So you can switch it for me. I mean, you can put it upside down, and I still will be able to see it. Otherwise, I wouldn't be able to drive.
Like that because of some people's colorblind.
Right, exactly. And mostly men are colorblind. Anyway, so now you know what I mean. So when I go back to the periodic table, if I say a certain color, you just know that I don't see it the way you do. I see the big contrast between this and that, but then these and these are not that different to me. They sort of blend together. Okay, what's the point of my discussion here? Well, that things that are pink here all have some common properties. They are the same in some ways. Because they behave the same, chemically speaking, in some ways, they have a special name. These are called the alkali metals. Just a name. These guys at the very end also have a name. These guys, what are they, green? Are called the noble gases. So they have a special name. These guys in group 17 are called the halogens. Halogens, that's just the name. So let's take a look at the homework now that we have enough information, because I think we can answer most questions in the homework with the information we got in the first hour of the class. So here we go. I'm going to open first the homework for this chapter 4, and then we're going to go to the quiz. Okay. So, if you have a periodic table in front of you, you can easily look for zinc. Well, easily, not really, because it's not alphabetical. So that's another thing that I forgot to mention. The periodic table, I forgot to remind you that lists the elements in increasing number of size by atomic number, starting on the left. So 1, then goes to 2, then goes to 3, 4, 5. It keeps going up. And it goes up from left to right and from top to bottom. Now, finding zinc is not that easy because this is not alphabetical. So you have to start looking And if you don't know the symbol, it may be difficult to find. I mean, I got lucky and right there it is. So zinc, which is the question in the homework, what, I have it somewhere else, sorry. Right there, has a symbol ZN, and that's what you're going to write. Okay? Now, one thing about symbols, you have to write the first letter as capital and the second letter as lowercase, or it's going to give it to you wrong. So let's put ZN coming from the periodic table and submit it. Boy, it's taking forever.
You guys having a hard time finding it on the table?
Yeah.
Which one are you looking for?
She has a different one, so I'm trying to find hers.
Yeah, so you can always find, and the book has one, but you can Google the alphabetical one, where it lists all of them alphabetically. That way you don't have to struggle. But you see, it's that easy, right? You
So
find.
my only question is underneath it, for mine, it says a chemical reaction does not occur for this question. What is?
I don't
what
think
is
you need to
that?
click on that.
Okay. I'm
Just
like, what is
ignore it.
that?
I think, let me see, does it? Oh. It doesn't let you answer if you click on it. So I just clicked on that, and it blanks this out. So yeah, just ignore that box that says a chemical reaction does not occur in this question. Okay. So each of you are going to get a different one. Just look them up. Wow, there's so many of them.
Yeah, mine's are like way different from your examples.
That's fine. Just find them, and I think you'll be fine. Just double check. Okay. Let's go to the next one. So this is the next question, maybe different on your end. So it's listing Li, Na, K, Rb. Well, let's see where we find those. I'm going to try to put them side by side here.
Oh, right here. These. What are these?
If I can put the periodic table here. Okay. So we have it side by side now. They have Li. Let's find Li right there, right? And then they have Na. That's right below. So these are all on the same group. This group, the name is right here, alkali metal, and we are given these choices. So we're going to choose alkali metals for this particular question. It may be different for you. There's only really four names that you need to remember. Alkali metals, alkaline earth metals, the second one, halogens, 17, and noble gases, 18. Those are the four that you need to know.
Which one is antimony?
Which one is what?
Antimony?
Antimony is, oh my God, I forgot I used to know all the symbols. It has to be.
Oh, it is?
SB maybe.
AMSI?
Oh, right there. Oh, it's on the mouse.
It's SB?
SB, yes. There it is, 51. Why is it SB? Because it's probably the Latin name. It's probably the Latin name in Latin or in Greek. The symbol has nothing to do with, yes. Many of them do, but some of them, like silver, Ag. That has nothing to do with silver. Well, it's argentum. Okay, so let's go to the next question.
Identify the group of.
Sorry?
I'm sorry, I'm reading. Sorry.
Oh, okay. That's okay. Okay. We're on the third question, and here they want to identify the group or period number described by each of the following. Contains the elements B, F, and NE. Where are, oh, there is B, there is F, and there is NE, fluorine, yes, and NE. But we're looking at what is common about those three. What do they have in common? They're on the same period. So all three of them are in period 2. So you're going to put, okay, so they don't want any words. They just want a number and a letter if necessary. So we're going to put a 2. See what happens. Because it's period 2. And it gives you a little bit of feedback, which is always a good idea to read. These three elements are located in the second horizontal row on the periodic table. This is period 2. Periods run from left to right. So let's take a look at the next one. It says, what begins with fluorine? What on the periodic table begins with fluorine? Well, we find fluorine. This group begins with fluorine. 17 now. Let's see what happens when we enter 17, because there may be expecting 7A, which I hope you put 7, and it was correct? Okay. And then let me put 7A.
It does show 7A.
Oh, it does.
In
the answer.
Information when it gives you the feedback.
Perfect. So let's put 17 then so that I can see the feedback. Right. So the old system again, 1A, 2A, 3A, 4A, so on and so forth, 3B, 4B, 5B, so on and so forth. Sorry about that. That's just a carryover of the old time.
I'm sorry, this doesn't have to do with this chapter, but it made me remember something and it could go for the exam.
Uh-huh.
The last chapter for the specific heat formula,
Uh-huh.
the quiz and the homework didn't take a negative answer, only a positive
Only a
answer.
positive answer,
That
okay.
would be the same for the exam?
Yes.
Okay.
So remember that I emphasized when we talked about specific heat that the symbol is important because it tells you whether you are losing or gaining heat.
Yes.
The book doesn't care.
Okay.
So you always use absolute numbers for the difference in temperatures. Just ignore the negative sign when you see a negative sign. Thank you, Rachel, for that. Okay, so let's go to the next problem, just to see different kinds of questions. Okay, so here is the GPS question. Give the symbol for the element found in group 14, period 2. So group 14, period 2. Oh, we are right there. Would you agree that that is carbon? In my example. So I'm going to put carbon, capital C. They don't want the word. And let's submit it. How about a noble gas in period 5? That is asking you to remember two things. That this last group is called the noble gases. And then we're going to look for period 5. 1, 2, 3, 4, 5. Xe for xenon is what we enter on the answer. Okay, I think you get the message. Let's go to the next type question. Well, write the chemical symbol for aluminum. Well, you had to find it in the periodic table. It's right there. Al would be the symbol. That's not a capital I, it's an L.
It's a L?
It's an L. So it's not AI,
It's
but
AL.
AL, unfortunately. Yeah, it's not very clear. Okay. So I think I can give to go to the next one. I want to see one that is a little bit more, all right, here. Your question may be slightly different, but the one that I have here says, choose the appropriate description for an electron. So what describes an electron? Let's take a look at the first choice. Negative charge, that's true, right? Yep. Small relative mass, yeah. I mean, we said that it was like 0. And found outside the nucleus. That sounds like it describes the electron. Let's go to the next one. Negative charge, yes. Large relative mass, that's wrong. So let's skip it. Positive charge, that's wrong. Neutral charge, that's wrong. So it has to be the top one, at least on my example. So let's pick that one. In fact, let me pick a wrong one. No, you probably don't. It's slightly different. The idea is that it's the same type of question. I'm on number 6. I'm submitting the wrong answer on purpose just to get some feedback. And it just says incorrect, and then it refers me to a page in the book. Okay, so let's change it to the correct one, submit, and let's move on to the next question. So far, so good. I'm going to skip this one. Read them carefully, of course, but I want to get to the challenging ones. What? You think it was challenging?
Yeah.
Oh, no.
Said yes, please.
Okay, more challenging.
Yes.
Okay, let's take a look at this one then. Let me not skip. How many newtons are in an atom of sodium that has a mass number of 23? So how do we do that problem? What would you suggest we do? If we want to know the number of neutrons in sodium, and we are told that it has a mass number of 23, any suggestions? So remember two things. The atomic number equal number of protons, right?
Oh, so find it on the chart and see what the atomic number is and minus that from the atomic mass.
Exactly. Exactly, because the atomic mass is the number of protons plus the number of neutrons. So in this case, we have the atomic mass, or the mass number, so that's 23. We're going to subtract the atomic number, because that's the number of protons. So minus, if we go to the periodic table, we find the atomic number of sodium is 11. So it has 11 protons. So 23 minus 11, this is mass, protons, this is going to be neutrons. Okay? So the answer has to be 12.
And the answer should never be like the decimal.
Right, because they're not doing the weighted average. They're doing the isotopes. Either they're going to be all whole numbers, yes. Very good observation. Okay, so let's go to the next one. There's one that I want to get to. Okay, so in this one you are asked to write the name and symbol of the element with each of the following atomic numbers. So you have to write both name and symbol. You need to enter the name and symbol separated by a comma. So let's make sure that we do that. Atomic number 4. So 4, 4, 4 right there. And they want the name first. So we're going to copy it without making any spelling mistakes. 2 L's, beryllium. In my case, it may be different for you. So beryllium, comma, Be. In my case, may be different for you. And it liked it. Okay? That's the next type of question. Let's move on to number 10. Oh, this is the one I wanted. This is the one I wanted because it's going to make you think, and it's actually a good exercise. Do any of you like doing crossword puzzles? Or my daughter does yeah, and she's really good at it. Are you guys good?
Feelings. Those are complicated.
Well, I do sometimes the crossword puzzles, but not very often. This one reminds me of that a little bit. So let's take a look at this table. And every row on this table has enough information for you to get everything else that is missing. So let's take the first one on my example. Zn, can we find the name of that element? Zinc. So you're just gonna it says fill each sentence to complete the first row from the table. Oh, cool. Okay.
So the row is going the horizontal?
Horizontal, yes. Now let's see if let's stay with the table and not even look at the questions here. Can you guys help me find the atomic number of zinc? Is that something difficult? No, it's not. You just go to the periodic table, you find zinc, and I find that the atomic number is 30. So that goes there. Now, what would be the number of protons for zinc? The same thing as the atomic number, so 30. So you put 30 here, 30 there. Number of neutrons, how do we get that? We just did it over there. So you're going to get 66, the mass number, minus 30, and that goes there, 36. Now for the number of electrons, let me just emphasize something because later it's going to change a little bit. But for this chapter and part of chapter 5, the number of electrons is always going to be equal to the number of protons. So don't overthink it. If you have 30 protons, you have 30 electrons. Later we're going to talk about ions. Ions are the same type of atom but with less electrons or more electrons than the one found in the periodic table. So we'll get there when we get there. Look at this one. The second one is really cool because it's kind of a mysterious one. It gives you the atomic number but nothing else except the number of protons. So can we find the identity? Yeah, we look for number 10 here. Oh, it's neon. So we're going to put neon, Ne, mass number. Well, we have the number of protons, and then we have a number of neutrons. So what is going to be the mass number? If we have that number and that number, what is this going to be? 20, yes, 20, 10 plus 10, 20. Number of protons, 10. Number of electrons, 10. So I think you get the idea. You can actually complete it just by thinking and using that connection between atomic mass and atomic number. That. Now let me see here. So this one, I guess you had to drag, right?
Yeah.
You use drag like that, etc., etc. Okay. And then they have more. All of that based on that table or what? No, maybe not. Maybe yes, maybe not. So this one looks like a lot of fun. Play with it. Remember, you have unlimited number of attempts. And then let me know next week if you have any questions. Let's go to the next one. I think the rest are all the same. Variations of the same theme. Let's take a look at this one. This one is probably a little bit more tricky. So we have an element symbol, SR. We have two numbers, 89 and 38. And they want for you to write the number of protons with a comma, then the number of neutrons, another comma, and then the number of electrons. So what would you write for that one? SR 3889.
Okay, the mass is 89.
Right?
Protons and neutrons.
So this is what I propose we'll write. They want the number of protons first. That's always the smaller of the two numbers, because that's the atomic number of protons. So 38, comma. Number of neutrons. We don't have it here, but we have the mass. So 89 minus 38. Oh boy, that 81, 61? My brain is not working. No, that's 99. So 51. Would you agree 51 is the difference? So that would be the next number that you write, and then comma, and then they want the number of electrons. And remember, for this chapter, same number of protons as for electrons, so 38. And that's what we write. So 38, comma, 51, comma, 38, and submit. And we got it right. Then there's several more examples which are the same. Okay. So let's take a look at this problem. So we have a very generic question, if you will, with not much calculations. It's more like you have to eyeball the answer. You have to guess it. It tells you that carbon has several isotopes, all of them found in nature. And they want you to choose from these 4 choices which one is the most common, the more abundant, with no more information. Well, they tell you, look at the atomic mass for carbon. The atomic mass for carbon on the periodic table is 12.011. Remember that this 12.011 is a weighted average of all isotopes. Now, if you take a straight average of 14, 12, 13, and 10, you're not going to get the answer. That's the straight average. So you need to see, okay, there's one of these 3 that must be more abundant and that is pushing the average in its favor. It's pushing it towards 12. Well, the answer has to be, well, it has to be a number close to 12. So carbon 12 is going to be the most abundant of all the choices simply because this number is close to 12. That means there's more of that than anything else. It's a little bit more complicated for others. Let me just answer it, and then I'll show you on the periodic table some isotopes that are a little bit more difficult. So for instance, let's take a look at chlorine. Chlorine has an atomic number of 17, but look at the atomic mass number of chlorine. It's 35.45. It's not favoring one number. It's not 35, and it's not 36, which are the 2 numbers that's around that. Okay? So what do we do there? We don't have enough information to answer it. It may be tempting to say, well, it's closer to 35 because 0.45 is closer. If I were to round this up to 2 significant digits, what would you answer? 35. So that's the way to say, oh, maybe it's the 35 isotope that is more abundant. But it's so close that is more difficult. When you have 12.001, that's so much more obvious, right? Okay. So just keep that in mind when you don't have more information other than the average atomic mass. Okay, 3 more problems and we're done with homework 4. Okay, now I need to shrink this a little bit. Let's see if we can, oh well, here we are dealing with chlorine precisely. In fact, there's no such thing as 36. Now with this information, now we can probably answer the question. 35 is going to be more abundant because it's closer to 35 than to 37. So, isotope 35 is more abundant, so we're going to drag that to the space. Isotope, oh, I don't know if they want this one or if they want this one. Let me reset it. Yeah, I don't know which one they want. I think they want that one. Well, because it's mass number 35 is the atomic mass of chlorine, which is... Yeah, I'm getting confused here. Yeah, I would say closer to. So that's what I think I'm going to submit as my answer.
So if it's 12.011, is that closer to or just 12?
Okay. No, C12 I would put.
Oh, okay.
Yeah.
That's what I put.
Don't submit it. Let me submit it so you don't lose an attempt. You have a very good question there because you could actually put 35 here, but I already used it over here. So I think it has to be the way we had it right there. So we're going to submit it and see what we are told. Yeah. So that's the way. Go ahead and
So it's C12.
C12, and then you're going to have,
And then closer to?
yes, 12 and then closer to, yes. And that should be correct. Mhm. So submit. Yes, you got it. Okay. One more problem, no, two more problems and we're done with the homework. Okay. So in this question, they want the number of protons, followed by the number of neutrons, and finally by the number of electrons, using integers and separated by commas with this information. We already saw a problem like this before. Okay?
Does it have the NP and number?
Yeah, it's just basically number of protons, number of neutrons, number of electrons, yes. It's a little confusing, I agree. So that would be 80, 115, and 80, right?
Isn't it 95?
I did it in my head. 195 minus 80, I think I said it was 115. I don't know. My brain is kind of getting tired. I'm trying to do this thing called intermittent fasting, so I didn't eat anything this morning.
I cannot do that all day.
I'm trying to.
That's 115.
Okay.
115.
So then it's going to be 80, 115, 80. That's going to be the answer. Okay? Number of protons, 80. Number of neutrons, 115.
She got it wrong.
Number of electrons, 80.
And I got it wrong.
Really?
115.
Okay. Let's take a look.
Wrote it wrong? Yeah.
So number of protons first, 80, comma, no space, number of neutrons, 115. 115 plus 80 is 195, right? Yeah. Comma,
Did yours say right?
80. I don't know yet.
Oh.
Here we go.
I have the same exact, what the heck?
Yeah, what?
I'm like, I can't show you.
No, I want to see it because I do believe you, but I want to know.
Mine is off by one number.
Ah,
Is yours off by one
Yeah,
number?
it's
trick
wrong.
question. So what was the number instead of 195 is what?
I have.
Ah, there you
I
go.
have 202, so I had it right in my count that I did. Let me go to the one that
Yeah.
No, it's the same. Wrong.
122.
I have 124.
Do it with
Got
your
right.
do it with your numbers and see what happens.
That's why I was there.
So this is, I did mine. I know.
So when you fixed it, it worked?
Because I did it
How
right
about
on
you,
my
Rachel?
side, but when you guys said it,
I'm so
Right.
sorry.
No, don't apologize.
Oh, okay, I did mine. It's cool.
Good. Okay.
198 minus 202. You have to do 198 minus 80.
Mine was 2.
So it changes it for every one of you. So you just be careful with the numbers that you put. They're different from mine.
I did it, and you guys said 115. I'm like, is this number?
Right. So you need to trust in yourself. Okay. So last problem. I think this is kind of easy. Let's take a look. So calcium has several isotopes. The most abundant is calcium 40. How many protons, neutrons, and electrons are in this isotope? So when you see the symbol Ca40, so I need your attention for one quick minute here, everyone. This is the mass. Okay? It's the mass. It's not the atomic number. So calcium 40 has an atomic mass of 40 and a number we had to look it up in the periodic table, but I think it's 20.
It's 20.
So this is the atomic number. So then 40 minus 20 is 20. So the answer is going to be, for mine, 20, 20, 20. It may be different for yours. Okay. Okay, let's do this one together because it may be tricky to choose. Actually, I do want to do this one. Okay. Everybody needs to give me your attention because the template that we're going to choose is a little tricky. So what is the atomic symbol of another isotope of calcium with 24 neutrons? So let's put the symbol here. Calcium is Ca. They want it this way. They want the big number on top, the little number on the bottom. We know the little number is 20, right? Now, what will give you as a mass number if you add 20 plus 24? 44. This is what we're going to try to enter in here. And the template that you choose, so you're going to click right here on this box, templates. Please do not use this one.
Oh man, I would have used that one.
Don't use this one. Use this one. Not the one with the dash because that's a fraction. So okay. I chose it like that myself the first time. So we want this one right here. And now if you see, it just gives you the space for the two numbers, not for the symbol. So we're going to do that last. We're going to say 44 and 20. So 44 and then 20. And then we're going to move the cursor to the next space and put the symbol, Ca.
I have silicone.
You have silicone, okay. And I'm going to submit it. So that's the template that you guys use, okay? Not the one with the little line. Same thing with the next question. In this case, they don't give you the identity, so we need to find out what element 21 is. I'm going to go to the periodic table. 21 happens to be scandium, okay? So let's go back. Where am I? Oh, right here. So template, that one, 45, 21, and then scandium.
The 24 is the mass.
The 24 is the number of neutrons.
Okay.
So you need to add the two together.
Yeah.
Okay. Now the quiz should be the same type of problem, so I'm going to leave those for you to try.
Can we do the silicone?
Should we do silicone?
I have all different.
What are the numbers? Let me see.
The silicon is 16 neutrons.
Okay, so let's look at silicon on the periodic table with 16 neutrons. So silicon, group 14, period 3, Si. And then how many neutrons did you have?
16.
16. So we're going to put 14 and then 30. Right? That should be the answer. Let me take a look at yours.
Magnesium.
Okay, and what else do they give you? Just the number of neutrons. Okay.
Neutrons are 4.
So let's find magnesium right here. So 12 is the atomic number. So we're going to write Mg 12. And then what was the number of neutrons? 14?
It's a 14.
So 16, 26. Right? Okay. Let me just make sure that I covered everything that needs to be covered for chapter 4. Before we move to chapter 5. Mm-hmm. Yeah, so it looks like we covered everything. The only thing that we didn't do is the weighted averages. But since there's nothing in the quiz, you know what? I'm going to open the exam and just make sure that there's no weighted average question there, because I don't want you guys to be struggling with that. So here comes a first look at the exam.
It's there.
I'm going to go very quickly over the exam, you guys. So this is your preview of the exam. So 50 questions. That's the first question. I'm just trying to find out if there's a weighted average question. If there isn't, I'm just going to close it. So,
Don't open it.
I don't have it at all. I don't have it.
Because you have to finish. Yeah. You do it, yeah.
I know, but I don't have it.
It's a homework.
it's not showing up.
I don't think I had it anyway. It's in it. He sent it last night.
So it has to be on the calendar? Because I'm seeing here, I don't have it.
Yeah, I don't have it on that little.
Oh, it's not there yet. Let me put it there. Hold on. Let me fix that, yes. You have a good point.
Not even in my calendar. Not even the calendar, I don't have it. I just want to make sure I see it.
Oh, there. Bless you.
Thank you.
Okay. So it should be visible now. If you go to the bottom,
I see it, yeah. I see it
you see it now?
Yeah,
Okay.
the big letter E, X, whatever, yeah, there you go. See, yeah, I just came in today.
So click on that and then you'll see the exam link there. But don't open it because I'm opening it here for you. I just want to make sure that there's no weighted average problem here. What is this? Homework. We don't want that. We want...
So can we do the exam like now, like later?
You can certainly start it today if you want to, yes.
And when you start, you have to finish?
Yeah, when you started.
No, you can close it and come back.
Okay, all right.
I want to make sure I don't
Yeah,
stay
because
stuck.
I said,
Same,
sometimes they lost it like that.
same rules. Yeah, no, and if you do lose it, please let me know and
All right, awesome.
I'll fix whatever problem there is.
I know. Perfect.
Yeah, it doesn't say that it closes in any time. Now, remember that you can print it. Okay? You click print twice. First there. You have to click right here, and then it's going to open a new window, and you're going to click on the right where it says print again, right here on the right. And then that brings you to your printer dialog, and you can choose PDF instead of printing to paper. So you save as PDF, and you can save a copy to have it with you. Okay?
We have to break that here, that paper?
No. It's for you to be able to work at home.
Okay, got it.
No, please submit it online. Okay, so let me take a look at all the questions.
This is only one try only, right?
Only one attempt, yes. But just remember, you can go back and look at your quizzes, you can look back at your homework. They're similar, if not identical. I'm just trying to see if there's no weighted average.
Because look, we have, so it's gonna be what, the fourth? Right? And then this one has to be done by the fifth. Remember, I still have math and cartoon.
It's a long exam, you guys. Okay, so there's no weighted average problem, but it is a very long exam. It's going to take you a good hour and a half to 2 hours or more. Yes. And then again, if you have any concerns, send me an email so that I can address them quickly. Okay. So let's spend just about 10-15 minutes getting chapter 5 started. Just because it's going to come very quickly. Okay. You know what? Not even 10 minutes. It's going to be a quick introduction to chapter 5. Good luck. I don't think there's anything you're missing from Wednesday, so don't worry about Wednesday. I mean, if you're welcome to come. Okay. Bye. Good luck. You're welcome. Okay. So just a quick introduction to what comes next. So the periodic table is going to continue to be the topic of discussion in chapter 5, but we're going to take a look at a number of important ideas. Now, I'm just going to draw a periodic table quickly here. One, 2, 13, 14, 15, 16, 17, 18. Okay. In this next chapter, chapter 5, we're going to look at a couple of things, but one of the things that we're going to look at is something called trends. When you look at the periodic table, one thing that comes immediately clear, I hope, is that the size of an element increases from left to right and from top to bottom. So the size, atomic number, goes up from left to right and from top to bottom. I mean, that's an obvious one, right? Mm-hmm. So if you take an element that is located here and you compare it to an element that is located here, this one is bigger. It should become immediately apparent to you. Now, that is not the same as something called the atomic radius. So we're going to look at something called atomic radius. If I draw an atom here with the circles as I had before, the so-called shells, the radius of an atom is the distance between the nucleus and the outermost place with electrons. Okay? Now, this is going to be a trick question. And let's compare first apples with apples. And then we're going to compare apples with oranges. Let me open up here an image. we're going to compare two simple atoms here so that you don't forget the trend of atomic radius. Now, the easy one is from top to bottom. The atomic radius increases just as before from top to bottom. But what happens here? The radius decreases from right to left instead of increasing. Okay? Let's see why. So the atomic radius, instead of the size of the atom, the atomic number, which increases from left to right, if I put hydrogen here, hydrogen has 1 proton. If I put helium here, helium has 2 protons, so this is the atomic number. I think it's obvious that it goes higher from left to right. But the radius gets smaller from left to right. In other words, increases from right to left. Why is that? Okay, let's take a look at two different atoms. So this is going to be helium, and this is going to be hydrogen. Hydrogen has 1 proton and 1 electron, right? Simplest of all elements, 1 proton, 1 electron. Remember what we said before, positive attracts negative. So this one positive is attracting this one negative. Helium has 2 protons and 2 electrons. But what I'm telling you is that the size of these compared to that is a little bit shrinking. The reason for that is because 2 protons are better at pulling the 2 electrons than the 1 proton is at pulling 1 electron. In other words, the more protons you have in the nucleus, the greater the force with which they pull the electrons towards themselves. So they tend to shrink the atom. Does that make sense? I mean, it's counterintuitive, but because you would be thinking, well, you have more protons, it should be bigger and bigger and bigger. But the electrons are being pulled more and more and more towards the center, even though you have more electrons. Now, when you go down a period, the reason why it doesn't decrease the way we just described is because, of course, now you're adding more and more and more layers, orbitals, shells. So it's bigger and bigger and bigger. This one has only 1 shell. In fact, I drew 2, but I didn't need 2. It has only 1 shell with electrons, nothing else. The rest of the atom is empty. Okay? Now, next week, I don't want to start the chapter 5 in detail because, 2 hours into the class, we're beginning to get a little bit tired. And the information that is coming next requires for you to be fresh. So I'd rather present it at 8:15 than at 10:30. Does that make sense? Okay. Any questions before we close the class?
For the atomic radius, you said it decreases from what?
The atomic radius decreases from right to left. Right, so it increases the same. I'm pointing to the left because this is smaller than this. And again, we're going to explore this in detail next week. Okay, so if you don't have any questions, that's it. We're done with chapter 4, thank goodness. And now we can start chapter 5. All right. Thank you.
And for the lab, this week, is it number 5 or number
Yeah, so good question. I think I put number 6 already there.
Okay.
So it is, the one due is number 5, but start working on number 6, which is related to this chapter 4. Okay? I think you're going to like that lab. Yeah, I think you will. We'll take a look at it next week.
Awesome.
The density, I didn't take a look because it's almost the same as lab 4.
I did not.
Okay, good, good. Please don't fall behind, you guys. I need to report midterm grades. If you don't see a midterm grade, that means that you're doing better than a B or better. If you see a grade, that means that you have C or lower. I don't think any of you will be seeing a grade. So don't have a panic attack. That means you're getting better than B or better. Okay, I need to erase. Oh, I dropped it over here. Before you go, let me, so Marie, Anne-Marie, and you are?
Celeste.
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 Okay, with a C.
With an S.
With an S. Okay, got it. And? Lara. Lara sounds better. Okay, thank you. Lara, and Marie, and Rachel, and Agnes. I had 200 students this semester, so remembering everybody's name. I mean, some of them are online, but I still have to sort of know who is who. Okay.
Express your answer.